My name is Michael Denker from Jülich Research Center, Germany. The high-performance analytics and computing platform plays a central part in the HBP design that enables scientists to jointly perform their research using computational tools emanating from the various sub-projects and beyond. One particular situation where the collaborative approach of the HBP unlocks its full potential is the aim of comparing and validating datasets from multiple sources, so-called integrative loops. Functional activity data recorded during experiments, and model-driven network simulations based on structural data and theory are validated using standardized software tools and data structures such as the electrophysiology analysis toolkit or Elephant. In the following, I'd like to give you a demonstration of one particular instantiation of this type of workflow that demonstrates how we envision that the collaboratory will help to interconnect the work performed across the various projects and platforms. Different approaches to simulating spiking neural networks are being pursued in the HBP. On the one hand, traditional simulations using highly scalable simulation software running on high-performance computers such as the NEST simulator. On the other hand, two neuromorphic hardware platforms are developed within HBP. One of these is the SpiNNaker system, which simulates neuronal activity on the basis of the chip technology you find in your mobile phone. To what extent are the results from these two radically different systems for simulation indeed comparable? To approach this question, one may consider to compare the neuronal activity obtained when simulating a complex model of the layered cortical microcircuit composed of about 100,000 neurons and 1 billion synapses, a model which is by far too computationally demanding to run on a single PC. I will now briefly demonstrate how the HPAC platform and the collaboratory enable to simulate the model of the cortical microcircuit using the NEST simulator on the JUQUEEN supercomputer, simulate the exact same model using the SpiNNaker hardware, pool the data in a central location, validate the results by a battery of comparisons using Elephant, and visualize the results. This task requires that many experts of different backgrounds work together to achieve a common goal. Naturally, in the HBP approach to collaboration, these scientists would start by building a collab for themselves in order to perform their joint research into this question and share their ideas, data, and results. From within the collab, scientists access the HBP infrastructure to perform the NEST simulation of the microcircuit. To do so, they run a configurable task in the collab that uses Unicore to launch the simulation on the JUQUEEN supercomputer. After completion of the task, the results are transferred back from the JUQUEEN supercomputer to the central collab storage and are accessible to all collaborators. The full information about how and on which hardware this data object was recorded is available to all collab members. In the meantime, a different group of scientists have performed a simulation of the identical microcircuit model on the neuromorphic SpiNNaker hardware. This data, likewise, is uploaded to the collab storage. The data analysts in the collaboration can now interactively explore the data using a Python programming shell. The readily available Elephant library empowers the scientists to not only easily load and visually compare the activity patterns of the NEST and SpiNNaker simulation across the different cortical layers, but to interactively perform a series of analyses on both datasets using the exact same methods. For instance, the data analysts may want to investigate not only the activity of these single neurons, but the coordination between neurons. As a first step, the analysts could calculate the distributions of correlation coefficients in the different layers. The analysts detect a slight deviation and decide to perform a more thorough analysis to investigate the detailed correlation structure. However, analyzing the complete correlation graph is too computationally expensive to run interactively. Here, the analysts turn to the task framework of the collaboratory and construct an Elephant-enabled analysis task that runs on a Eureka supercomputer using the Unicore framework. To make sense out of these complex correlation graphs, the analyst provides the data to the visualization team within the collab, which experiments with novel, graph-based paradigms to help scientists understand their data and results by interaction. The movie shows the interactive analysis of two correlation graphs of the network. Future work aims to make such interactive visualizations available directly to other scientists' collabs. This short demonstration has shown how the Colab can help to structure a large collaborative workflow, integrate various software tools of different experts, from simulation to analysis and visualization, and how it can bring this science to the supercomputers. The full demonstration can be found as a Colab on the HBP Collaboratory.